Okay, so here's problem 3. This one's fairly straightforward, like problem 1. We're given that we have been given the x and y components this time, and we're supposed to be finding vector A. So we have our coordinate system here. We have A sub x going negative 25 meters in this direction, and we have A sub y going 40 meters in this direction. So basically, we're just going to make our other vector here, and this is the one we're looking for, right? If you want, and it doesn't matter, this vector here could be slid directly up here. As long as it makes a right triangle and you're doing tip to tail and it makes sense, you can do it multiple ways depending on the problem. So just keep that in mind. If you did this yourself already and now you're just watching it and you're like, oh, why does it look different or something like that, they can look different a lot of times. Okay, anyway. So from this, we're just going to use our Pythagorean theorem. So all we need to do is take negative 25 squared plus 40 squared and square root that. So that just comes from the simple points of we have the two sides of the triangle. We know the hypotenuse is what this equals. Put the equal sign on this side. And you should get about 47.17 meters, which we can just say is 47.2 meters. So this gives us the magnitude of this vector. The next thing is we want to find some angle. And I will just make this theta. So from here, we're just going to use our tangent because we can just do opposite over adjacent. We already have those two pieces. You can, at this point, we have the hypotenuse, so you could use a number of ways to do this. But just in case you didn't do this part first and you're looking for the angle first for whatever reason, we'll just do tangent equals opposite over adjacent. And for this part, I don't think the negative sign matters, but when you do this, you're going to solve for theta. And to solve for that, you have to do the inverse tangent of both sides. So when you go to put this in your calculator, just put inverse tangent of 40 divided by 25. And then theta should equal, it's about 57.995 degrees. So we're going to say that's approximately 58 degrees. And then we just subtract 180 to bring this back around. So you have 180 minus 58 equals 122. And so that's it. So you have the angle, and then you have the magnitude right here. And that's both components to the vector.